Hello everyone, this is Orhan. Welcome to Logistic Regression's lecture. In this chapter, I will describe a powerful classification method called logistic regression. The linear regression model that we described before assumes that the response variable y is quantitative, but in many situations, the response variable is instead qualitative. For example, color is qualitative, being married or not is qualitative, whether somebody graduated or not is qualitative. So this model extends the idea of linear regression to situations where outcome variable is qualitative, in other words, categorical. I will use these terms interchangeably. So in this chapter, we will study approaches for predicting qualitative responses, a process that is known as classification. Logistic regression is one of the best and popular methods for classification. It's widely used, particularly where a structural model is useful to explain or to predict. And we are going to focus on binary classification. So in this setup, y is going to be either 0 or 1. In this lecture, I will illustrate the concept of logistic regression using simulated default dataset. We are interested in predicting whether an individual will default on his or her credit card payment on the basis of annual income and monthly credit card balance. On the x-axis of this figure, you see the balance of customers, and on y-axis, you see whether customer defaulted or not. So if it is 0, this means the customer did not default. If it is 1, this means that the customer default. There is no y data other than 0 or 1. So imagine you fit a linear regression here, which is going to be something like this. So if you fit a linear regression, the predicted y values go beyond 1 and below 0, which is impossible. So in reality, there is no y values higher than 1 or lower than 0. So we have to have a function, we have to have a model whose values should be between 0 and 1. And that's the idea of logistic regression. So idea of logistic regression is that it fits a curve between 0 and 1. So the curve is going to be something like this. It's going to be an S-curve which does not go beyond 1 below 0. So that's going to be our main curve that we will see in a moment. And we will see how to fit an S-curve between 0 and 1 in a moment. Assume, for example, that I have only one feature, one independent variable, which I am going to use for predicting the probability of default. So I have this variable, which is, let's say, balance, and I'm going to predict the probability of default of customers. So basically, this is a linear function, and then, as I said, it goes beyond 1 and below 0, so which is not very efficient to calculate probabilities. That's why one function that we might use is called logistic function. So instead of using this linear model, we are going to use the following model. So probability of default based on balance is going to be something like this. E to the power beta 0 plus beta 1 times x divided by 1 plus e to the power beta 0 plus beta 1 times x. This function can never be higher than 1 and lower than 0. So it's between 0 and 1. If we somehow estimate beta 0 and beta 1, this function guarantees that we are going to be between 0 and 1. And this model is called logistic model, or logit in short. There's another function called probit, which stands for probabilistic function. In that function, we use cumulative normal distribution function, which is again between 0 and 1, just because it's probability. But we are not going to use that model in this class. So this model produces a S function curve between 0 and 1, something like this. So if there are y values here of 1 and there are other y values of here of 0, this function creates a S-shaped curve between 1 and 0. This function can also be written as follows. It is equal to saying e to the power beta 0 plus beta 1 times x divided by 1 plus e to the power beta 0 and beta 1 times x. So it's the same thing. Computers estimate beta 0 and beta 1 using a method called maximum likelihood. Let's draw this curve once again. There's going to be an S-shaped curve here, but the question is going to be, what would be the prediction for every x? Let's say there's an x of balance here, let's say $4,000, and the computer is going to estimate it as something like this, let's say 0.2. So what is going to be my prediction? Is this prediction default or it's not default? Well, basically there is something called cutoff. So people use various cutoffs. 0.5 is a very commonly used cutoffs. If the prediction is below 0.5, let's say this is the cutoff. If the predicted value is below cutoff, let's say 0.2, then this guy is going to be assumed as non-default. So these guys are going to be non-default guys. So these people all on this curve, this side of the curve is going to be non-default guys, and people who are beyond this cutoff, so whose predicted values are higher than 0.5, is going to be default guys. But you have to use 0.5 as a cutoff, but it's one of the commonly used cutoff points. Okay, consider this example once again. We are going to predict the probability of default of customers based on their balance. And this model that I showed you a moment ago is going to fit an S-shaped curve here between 0 and 1. And for every single X value, for every single feature here, balance value here, we are going to have a predicted Y value. And the model, the computers, the softwares are using a method called maximum likelihood method and calculate these values of the model. So let's remember the model once again. This model is 1 divided by 1 plus e to the power negative b0 plus b1 times x. So let's assume that these values are estimated as follows. Let's say b0 is estimated as negative 3.65 and b1 is 0.0004. The function turns out to be as follows. So this is going to be e to the power positive 3.65 and negative 0.004x. So if we know the balance of any customers, so we write the balance here instead of x and whatever the balance is, and then we can predict the probability of default of that customer in this very simple model. Let's assume, for example, that we are trying to predict the probability of default of the customer whose balance is $10,000. We are going to substitute $10,000 here instead of x, and this is going to be negative 4 plus 3.65. So this is going to be 1 divided by 1 plus e to the power 0.35. And this value gives us 0.58. So basically, the probability of default of this customer whose balance is $10,000 is going to be 0.58. So this is the probability. So are we going to assume that this customer is default or this customer is not going to default? This depends on the cutoff value. So let's assume that the cutoff value is 0.5. So cutoff value means if the probability is higher than the cutoff value, we are going to assume that this customer is default. If the probability is less than the cutoff value, we are going to assume that the customer is not going to default. In this case, so the probability that we calculated is higher than the cutoff value, so we are going to assume that this customer whose balance is $10,000 is going to default. If instead of balance we used income, then the setup is going to be different. So this time, the higher the income, the lower should be the default, of course. So this time, this S-curve is going to be something like this. It's inverse S-curve because the higher the income, the lower should be the probability of default. Okay, summary. Logistic regression is similar to linear regression, except that it is used with a categorical response. In this setup that we analyzed, y was a binary variable. It was either 0 or 1. It can be used for explanatory task, profiling, or predictive task for classification, but basically it's mostly used for classification. The predictors are related to the response y via nonlinear function called logit. There is also another function which is called probit, which is not covered in this class, but it's also very common. As in linear regression, reducing predictors can be done via variable selection. And most importantly, logistic regression can be generalized to more than 2 classes. So in this setup, we have 0 and 1, but basically there is another model called multiple logistic regression. In that setup, y might take values more than 2. So there might be more than 2 classes. I hope you enjoyed this video. In the next video, I will show you how to run logistic regression in Python. See you in the next video. Bye.